So let's begin. And if you have questions, please stop and ask. We don't want to stop all the time, but if you have burning questions as we go along, let's ask them. This is a tale of two cities, and it's a tale of any two modern coastal cities where over the last few hundred year or to hundreds of years, people have built large infrastructure. So this is our village, Manhattan, New York City, and what's striking about it is that it's built at sea level because we like to go and live and play at the beach, essentially, as a civilization. Taking another example city in the global context, our planet, you can see Greenland hiding off at the top there, and here's the city we're talking about tonight, yet another example of a coastal infrastructure built at sea level because for obvious reasons. And it's the same similar character of the waters next to it. On the Google Earth animation, you saw the world ocean, and the world ocean sea level is controlled largely by the behavior of the two great ice sheets, Greenland and Antarctica. Previously, going back 10,000 years or so, there was a large ice sheet here over New York and over Canada, and sea level was changed. It was 300 meters lower, so the beach was much further away. So this all changes naturally through time. So the setting is, first of all, thinking about, in the bigger picture, not sea level, of our global environment. And certainly to me, the moment that I found thinking about the global environment came from the first NASA video that came from the moon, looking at the Earth. I thought that really was remarkable. And so to me, this is the stage.
11, Houston, if that's not the Earth, we're in trouble. That's the Earth, and we have a very good view of it today. There are a few more cloud bands on than yesterday when we came down to you, but it's a beautiful sight.
So what's come about in the last few decades is really this idea of environmental science. And the challenge is, from a science point of view, and I'm really not addressing policy, just science, trying to figure out how that planet works. Why does it change? And just one element of it are the ice sheets and sea level. And that's what we're going to talk about. So the thing about sea level, the most striking thing, is yes, we know there are big numbers associated with it, but it's all kind of difficult to grasp. And what we're really interested in are projections. We want numbers that are credible that say sea level will be changing by how much, when. That's what you want to know. We don't have that. We don't have that, and anyone gives you an opinion about it, it's kind of not meaningful because we haven't done the science that would allow us to make those projections. So that's where we are. So what do we really know? There's an interesting piece of data. That's a 100-year data set. That's the planet Earth. That is perhaps the most important data set we currently hold. I certainly don't believe in global warming. That's a data set. You don't get to believe in that. It's just a piece of data. You don't need to interpret it or anything. It's red where the planet has warmed in the last 100 years. And that really is the point that we draw on, that whether natural or forced by us, that's a fact. And the implications of that going forward, we project for the next 100 years that that's going to look even more intense. Now we move from an observation, which is a fact, to a suggestion, and that is that warmer climate would melt ice in the polar regions. And ice in the polar regions, it's high and dry, it's basically on land. It goes into the ocean, sea level goes up. So that's a suggestion, and we've seen in the past, through records going way back in time, that the ice sheets oscillate and sea level oscillates. So why does it matter? Well, it matters in one sense for people, but it also matters for ecosystems around the planet. All of these cities, with modest changes in ice sheets going forward in the next century and the next centuries, all of these cities will essentially be flooded. And that's why people have taken this serious, none the least of the two that we're talking about tonight. The media pick up on this a lot, and you can pick up any kind of news magazine and follow this thread for the last, I would say, for a decade now. And you see these kind of cartoon sketches of water flooding into streets and that. And it's all very suggestive, But the actual science behind this yet is not established, and I want to get to that point in this talk. How is it we're going to move towards the equivalent of weather projections, the weather forecast for tomorrow? Where is the equivalent for sea level? And Abu Dhabi, also same idea. You can pick any of these cities, and then you can see that, yeah, if you melt the ice sheets, which appear to be far away, well, the water travels fast, and it will show up on your doorstep. The reason why we are stuck is two reasons. One has to do with physics, and one has to do with logistics. The image you're looking at is ice going from Greenland in the background, the Greenland ice sheet. The ice calves, it cracks off, and it goes from the land into the ocean. The ice sheet gets bigger because of snowfall, and it gets smaller and makes sea level go up because ice calves. This process, there is no physical model of that process, so therefore there's no model of sea level because everything's missing. The second thing is, physics aside, which I think if we set our minds to it, we could tackle this problem, and people are beginning to, it's the logistics. We also have not yet gotten our mind around the point that we're not probably as smart and capable as we think we really are. Getting to these places and setting up observational networks to get basic data is moving at a snail's pace. It's phenomenally expensive. It's amazingly slow. So just the idea that you're going to go somewhere and get data, it turns out to be difficult in Greenland, and Greenland, Antarctica, some other word, much more difficult than Antarctica. The basics. So, just so we're on the same page, how is it that you would actually change the ocean? When you walk down to Battery Park, and there's a little monitoring station, it's been there about 100 years with data, and you can see it. Sea level has risen about a foot in the last century. Very clear. What it is if you heat the ocean expands. And that's the projections we have currently, that we are warming the atmosphere, the ocean is warming, and that the ocean is expanding. That's one part. The other part is if you take ice sheets and you put them in the ocean and melt them, you also change sea level. And that's the part about adding water. That's the big part, and that's the part that we do not have the science to back up. The media and policy folks are way ahead of the scientists on this issue, and that's okay in some sense. They're doing what they can. But we are stuck with this problem of the science is not there yet, and whether or not we're actually going to arrive there anytime soon is a question mark. Let's look at some of the data that, again, about things that are for real. So this is data, and I want to focus on two data sets, the temperature of your planet and the sea level. It turns out temperature, here's the last 1,000 years, and so the last 100 years have seen a real acceleration and increase of temperature. This is what people call global warming. The reason for this doesn't really matter at the moment. That's a data set. It's called a hockey stick graph, by the way, because it bends up on the ends. You can see from people have hockey sticks. And the sea level, the data set is not as good. It's the last 100 years, but sea level is rising. That has a slope. And all we're really interested scientifically is about that slope. In the past, that slope has been 25 times steeper. There have been times when sea level just shoots up for a century. And sometimes it's slower and it goes the other way. So it's all about that slope, which is very modest now, but it's accelerating a little bit at the end there. And we want to carry that forward to 2100, 2200, 2300. That's what society will want to know in the next couple of hundred years. Where does that curve go? And at the moment, where it's going to go is we're going to observe it. We're not yet able to project it. And at some level, it's not determined yet if we will be able to project it. If it's such a chaotic and uncertain physical system that we, and it's not like the weather that you project every day and you do it for decades and you get it right. This curve, you get to draw once for a couple of hundred years. Nature does an experiment, and that's it. So an amazing challenge. What I do want to impress on this point is that the data looking back about the temperature of the planet and the level of the ocean Totally solid, credible. Going forward, you'll have to take my word for it, but the projections of air temperature are reasonable. They're projected to increase by a few degrees in the next century. And I think we kind of know how to do atmospheric physics. But sea level is an incredibly complicated problem because you'll see that sea level is controlled by ice. The ice is controlled by the projection of the behavior of the ocean. And the ocean is controlled by the projection of the atmosphere. So ice to ocean to atmosphere. You have to get it all right. So now we've really focused on these two ice sheets. And the two that are left at the moment are the one in Greenland and the one in Antarctica. This is kind of a weird projection, but nonetheless, you can follow it. The one that was sitting over North America here, which is here most of the time, the Laurentide ice sheet, it's gone at the moment, but it's most of the time it's there. And that's not really well understood. Why? In the next two parts, I'll take you to two specific locations on Earth. One in Greenland, Ilulissat or Jakobshavn, and one in Antarctica, Pine Island Glacier. The reason we'll travel there is because remote sensing, NASA satellites, as they fly over the Earth, they look down and they see two places on Earth where things have been changing rapidly in the last decade. And this is, when you look at the news, that's what they're talking about. The rapid changes occur there in Pine Island, and they occur there in Ilulissat, and some other places too. But those are two poster child type places for this science. And it turns out those are places that warm ocean waters are traveling. The cartoon, the particular, we're becoming extremely narrow now, but it's necessary to be specific. If you're going to talk about rapid change of sea level, this is how it's going to happen. You're going to have an ice sheet, which is a big thing over here, growing by snow. And under gravity, it flows forward into the ocean and calves. You saw the video of the iceberg calving and breaking off. And the ocean is coming this way, and the ocean is either warm or cold. If the ocean is cold, then the ice can advance. If the ocean is warm, it retreats. And that's the story of sea level on the short time scale. So that little red arrow will be the thing we'll be interested in. Are there warm waters or not? Is it cold or is it warm near those places? The two places we looked at, Jakobshavn and Pine Island, are two places that you can travel today on the Earth with great difficulty, and you can find these red arrows. You cannot see these red arrows from space. We can do a lot of great things from space with remote sensing, but the ocean contains salt, and you cannot see into the ocean from space. You actually have to get a sensor right there. That's why we don't have this particular piece of the question answered. If you can project these red arrows going forward for the next century, if you were good enough to do that, then your next challenge is being able to model and project how this ice would respond to it. And you're done. You have a projection. So that's the concrete, specific things we want to do. We want to observe this, and we want to build models of it so we can have projections, something to do. So, given that we don't have observations of these things, it would seem that you would want to observe them. It turns out, I started participating in this 2 years ago, and I have to say, it's certainly a lot of fun to go to these places, and frustrating. So let's go to each of these places so you get the particular character of each of these locations. In Greenland, if we travel up north, it's that feature up there, persistent ice sheet that stays throughout the ice ages. It's kind of always there. It's a fair amount of ice. If all of that were to melt, it would raise global sea level 21 feet. I don't think that's going to happen anytime soon, but it's a big reservoir of ice. This particular place, Jacobs Harbor or Jakobshavn, is the place that I became interested in. I was speaking to someone maybe 5 years ago, a glaciologist, and he said, in 1997, this glacier started to go twice as fast. And that's really caught people's attention. It was putting ice into the ocean, but then suddenly in 1997, it started doing it twice as fast. And it's still doing it today. And it retreated. The coastline retreated back, and people were like, oh, wow, that's interesting. It's because we have NASA sensing this from space. You can see this. And then the question is, why did it do that? Why did this thing suddenly retreat? Our theory was that that red arrow had showed up underneath that glacier, that the ocean had snuck in there. And it turns out that that was right. So that's the picture of the North Atlantic. And again, Greenland is that object. And what you need to think about is there's a lot of heat in the ocean nearby. And if you can take the atmosphere and you can just push warm water towards Greenland, then you have a response. And the same with Antarctica. Also, as an aside, in Greenland, doing science can be difficult. But there's also a lot of policy people there, and I think that's really wonderful. I met up with the US Congress science delegation came. We had a chance to explain our science there, and it's certainly more easy and more clear to explain something when you can point and say, we're talking about that glacier over there. And also, last year, there's lots of groups there from different countries in Europe, and the Scandinavian Royals were there, and it was really interesting to travel around Greenland with them. They were on a fact-finding mission, and they take that knowledge that we give them and they share it in a policy world. Back to the science, that's the fjord, and you look at it, it's covered with ice, and the question is there warm water underneath that? Well, you have to get in there. You're not going to achieve that by a boat. So we came up with using a helicopter and some borrowed equipment from the US Navy. So you'll see it here. So that particular fjord in Greenland, that's 800 meters deep. The top 200 meters is all cold water. And when you stick that probe that fell out of the helicopter, the bottom 600 meters is all warm water. So, okay, so today it's warm. Has that fjord always been warm? And it turns out that, well, there are not historical measurements like this. Yes? It's 3 degrees centigrade, and the freezing point is -3. So it's 6 degrees above freezing, whereas usually it would be at the freezing point, in which case there would be almost no melting.
They said the warm or the cold temperature you just mentioned.
So the warm waters would be +3, and they're deep in this fjord, and all the surface waters are all at the freezing point. And the warm waters are underneath, which seems surprising, but they're laden with salt, so that's why they're so heavy. So what we did is we went back to the fisheries data sets for Greenland, and it's surprising, but the folks who do fisheries in Greenland always put thermometers, which are not much bigger than this, on all of their fishing nets, and they've done this for decades. And working with the folks in Greenland, we got those data sets, and we were able to see that the waters along the entire west coast of Greenland, before 1997, they were cold, and after 1997 to today, they were warm. And those warm waters, flood into these particular fjords. So that is an example. And you don't need to attribute a reason to this yet. This is just very observational. The fact that the waters along Greenland were cold, and then in 1997 they're warm, and since then. And it's not about the actual warming of the waters. You can't warm water by 5 degrees in a year, the ocean. But the ocean has lots of warm waters in it, and you can redirect those. And that's what this story is about. This work is best described by this cartoon. So I would say that nothing to do with earth science almost is intuitive. We observe how the planet works, and then we learn it, and I think we memorize it, and then we think we understand it, but in fact we've observed it and memorized it. So that's what I will tell you, because this is what's true. The planet has these red currents, like the Gulf Stream, which are warm and salty at the surface. And it has these blue currents, which are fresh and cold. And the fresh, cold ones are there. And you can see that Greenland has kind of got blue currents near it, but it's got a little bit of the red nearby. And the story is, essentially, that as the atmospheric winds from North America to Europe, as those winds change, some of the subtleties in where these red arrows go change. And that's what happened. In 1996, the winds going across the Atlantic, it's something called the North Atlantic Oscillation. It's when the winds are strong or weak. The winds were strong for a decade. In 1996, they became weak. And then these red currents responded and started to slip towards Greenland and just filled up these fjords. But in Greenland, as I said, one more subtlety, the red arrows, because they're salty, go underneath the blue ones. So you can't see it from space. It sneaks in underneath. And literally in that fjord where you had the helicopter, that red arrow was deep in that fjord, and it was going in and attacking and melting the ice sheet. And it's driven by the changes in the wind. So if you change the atmospheric wind, which is a very subtle thing, atmospheric circulation, by whatever mechanism, natural, carbon dioxide, ozone, then if you make that change, the ocean will integrate that change within 10 years, and the ice sheet will respond. And either you bring warm water to the ice sheet or not. In this case, in nature, we actually saw it happen. We saw a glimpse of it. It happened. And the question is, will it happen again? And did it happen before? Yes, it looked like it happened in 1930 also. This was work we reported on for this area. This was also picked up at NYU. And Science magazine picked up this and a related study we did. We did two studies, one in Greenland about observations, and one in Antarctica about computer modeling, because there are not many observations. And there's a common theme came out, that is that the ocean responds quickly to changes in winds. So it's not about warming the ocean, I want to stress that. The idea is if you start playing with the atmosphere, then the ocean will respond, and that's where you're getting into probabilities of things happening. Yes?
Was there corresponding cooling in Europe if the Gulf Stream was diverted to Greenland?
A piece of it, yeah. There's that amount of heat that's no longer going to Europe. So why did the winds change? Research. And that could turn out to be very difficult to answer, actually. Very difficult. Antarctica. So what's different about Antarctica is the second part of the great ice sheets, is that it's 10 times bigger, and it's more of a concern. Because the part of Antarctica in the background there is not actually land, but it's ocean. So Antarctica, think of it as a continent with ice on it, but it has become so big that it has overflown itself and started to fill up the ocean through a long time. So it's actually in the ocean, the western part, and that's why we call it a marine ice sheet. So the ocean has no trouble in possibly interacting with that ice sheet because there's no obstacle. If you have ice on land, it's high and dry, the ocean cannot reach it. But if the ice is in the ocean, it's different. In Antarctica, when you stand on the ice in western Antarctica, it's 2 miles high. 1 mile of it is above sea level, and 1 mile of it is below sea level. It's a lot of ice built up a huge reservoir. And it also represents about 20 feet of sea level change potential. Our research in Antarctica, well, Antarctic science, just to give you a sense of it, it's expensive. We spend $300 million a year, our science agency, on just logistics and getting people in and out. Then we do science there, and typically it's $10 million to do this or that or the other thing. And what you can achieve is very, very modest.
So you had said Antarctica, the ice is maybe 10 times the volume as
Greenland? Yeah.
But if it all melts, it's going to rise about the same.
Well, yeah, so Antarctica has two parts, east and west. Altogether, Antarctica would represent 200 feet of sea level change. But the east part is high and dry on land, so I'm not factoring that. That's the Antarctic ice sheet, and the east part turns out to be the part on the far side of the screen. And Pine Island is this little place here. It's named for a Coast Guard ship from the end of the Second World War called the Pine Island. So our science plan, relatively straightforward. Again, this is early days of this science, is monitor the temperature below there, observe it, and find out if this is really true that red warm waters are there, and that's the response to whatever, and the glacier melts, and you'd begin to develop this empirical or heuristic argument that the ocean really does affect the glacier, and that's the story behind rapid sea level. If that's not the story, I don't get that there is a story. So we need to find out if that's true or not. In Antarctica, you can't use helicopters and just have your graduate student and drop probes out the window, because in Greenland you can go 100 miles away, you can get a helicopter and you can charter it, and there it is. It's all there. People live there. In Antarctica, if you want your helicopter brought over, well, you better put down your 10 million to start with. And how are you going to do this? When you start thinking the logistics of achieving things, it's complex and it's daunting. It also has this other complication that it has these large things called ice shelves where the ice comes out and floats over the ocean. And in some places, these floating ice tongues are the size of France. These big things, maybe 200 or 300 meters thick, vast expanses of ice that in order to get to the ocean underneath, you have to drill through. Or you could find some other way, but drilling is one way. So our plan starting 3 years ago, which has turned out to be not such a great plan, was to use the base from the US base near Christchurch, where you can get, just think about it, all I'm asking people to do is to travel to a particular place called Pine Island. When you look down from space, you see that every year this place is getting thinner and thinner and shrinking. And you say, okay, we will see what we can measure there. But you have to get there into the ocean. So the plan was to get the logistics from New Zealand to a place called McMurdo, where there's about 1,000 people. So you can get these Globemaster planes, which are from the Air Force, and they will take you there. Then your next part is you need to go to a hub. So the first place has 1,000 people in it, McMurdo. And then there's a place out here called Bird Surface Camp, where there are about 50 scientists. And you can get these Hercules planes from upstate New York, LC-130s with skis on them. And they will take you to the middle of Antarctica. But then if you want to get to Pine Island, they will not take you there. You need another type of plane, which comes from up North Canada, these Twin Otters, which can land or take off across runways. These are amazing vehicles. We went there and we landed on this glacier, and then the pilot said, we're not going to do that anymore. It was too dangerous. And so we pulled out, and that was the end of that. It was 2 years ago. So then the idea is, okay, so how are you going to actually do this? And the idea is helicopters. In January, when I went to McMurdo, my colleagues from New Zealand, they brought along their helicopters, and they just take it kind of as carry-on luggage. They just take it in and out of the aircraft. And that's really the way to do it, that with a team. So they just have it in the back of the plane there. That's my helicopter, and they carry it around. So it certainly can be done. This is what happened 2 years ago when we went there and we were told we could not go back. This is a Twin Otter, and this is a little bit of the camp that was set up. We're heading off. If you can see, we're leaving the waste galley where we had a very nice breakfast, and so we're heading out to the Pine Island Glacier up here, and we're going to install an automatic weather station. We hope a weather station will be installed in Antarctica. We've been here 3 days now, and everything's been going just great, because see in the background, we've got the weather tower set up, and to the side of that you can see the solar panels and wind turbine. It's been very almost balmy here the last few days, and we've also attracted some visitors here, some SCUA, who are very interested in our presence. Before, when I was contemplating our trek for Antarctica, it's a little bit more polar. It's gusting now about 20 to 30 knots. Wind chill is pretty cold, probably minus 15, 20. Makes it a little harder to work on this. We're carrying out research in such remote locations, not because they're remote, but because that's where interesting science is happening, and that's where we have to go to. These places are extremely difficult to get to, and at the moment they're even more difficult to get back from. Sometimes, if you're there, then it may be 2 or 3 weeks before someone comes to get you. In Antarctica, the weather has to be good at 3 locations simultaneously for you to be picked up. And if it's not good in 3 locations, we're origin, destination, and safety. The field season in Antarctica is only a month long. The amount of work you can do there is incredibly short. This year, that weather station was installed 2 years ago, and in the interim time, it has snowed in that part. The glacier has receded and melted, but at the surface, it accumulates, and so the weather station was buried. And the idea this January was to go and to put in a network of 6 weather stations to really start to monitor the atmosphere here. And within decades, we'd have this wonderful data set about the atmosphere. That got off to a rough start, but we'll go back next year. Essentially, what happened is I made it out here with our team to the center, to Bird Camp, where Robert Bird, from International Geophysical Year 50 years ago, that was set up. Pine Island, we sat at Bird Camp for about a month, waiting, and just writing down reasons why the pilots would say you're not flying today. So there were many reasons. Some were visible. They would come back on some other mission in the plane. They had crashed into something. The tail was hanging off. Okay. Other days, you'd look and you'd say, well, there's a New York Jets football game on. Why is it we're not flying today? Other days, pilots have rest days, and it goes on and on. There are a lot of reasons why. And then weather is the dominant one. So in a month, we made it to Pine Island Glacier and did science on the ground in a month for 4 hours. That's it. And then you pull out. The Antarctica's closing, so everyone has to leave. And that's what happened here. It's Thursday, January 28th, and today we finally made it to the Pine Island Glacier. And here we are, standing near the glacier. Looking to the south, the sky is beautiful. The sun is setting towards the south. And if you follow me around, and we turn towards
It's a little bit noisy here.
You can see the Hudson Mountains maybe behind me. That's where we're headed shortly. And we're going to install a weather station in that very remote location. We're stopping at our fuel cache. We have 12 barrels of fuel that we're picking up here, so we can fill up our armor, and then move on. All in all, a pretty good day. So we actually made it to that location, and other complication, and I'll focus on that a little bit, is just having 12 barrels of fuel show up on Pine Island Glacier so the plane can fly you back. That takes like another week because you need a bigger plane to get that in there, something called a Basler. Each barrel of fuel there, you think barrels of fuel are expensive? I don't want to wager, but each barrel of that fuel is like $10,000 a barrel. But it's just not so much its cost, the fact that you get it and put it there. How is it going to get there? The other part, that's it. That's Greenland and Antarctica. We work on it at NYU. Other universities work on it. Other countries work on it. But cumulatively, you have a snapshot of what we're trying to do, is basically make observations and models. Yes?
In that January field season, is it just your group that's out there in Antarctica, or are there other university groups, and are you all working on the same
We're all working
weather
on,
station project?
mostly working on different things, but for this particular sea level Pine Island, there's like 5 universities joined together for that. Yes?
If it's not all classified, can any of the drone technology which is used in Pakistan be used?
So that's
Context?
yeah. So that's what's happening in the next 3 years. Global Hawk is being brought to Antarctica, but it's going to fly very high at 60,000 feet. And again, it's going to do remote sensing of Antarctica, but it's not going to tell you anything about the ocean. So autonomous vehicles in the ocean and the air are being brought to bear on Earth science problems, and we'll move it forward, but it's very early days. Is that your question?
Well, yeah, I don't know.
Yeah.
How high they fly or how far what the range.
They can go
is.
across Antarctica, but they have to fly quite high.
Yeah.
Yeah. And they can be sensors can be put on them, and it will be impressive. Yes?
The fuel, aviation gas or jet fuel, if it's too cold, it won't burn.
This all works fine.
Okay.
Yeah. And we go in the summer when it's 0 degrees centigrade, and we don't operate in the winter when it's minus 70. So that's part of the answer.
That's a big one.
Yeah.
There's ocean underneath. How about submarines?
So nuclear submarines are not allowed by the treaty to go to Antarctica. So what we can do are autonomous vehicles, which are being developed from the navies. But autonomous vehicles don't travel to Antarctica. They require ships called icebreakers. And those ships, to get them there are only a handful of icebreakers on the planet. And to get their attention, either buy one or rent one is difficult to get it. So ships with autonomous vehicles, yes, you could do it. In general, in our science, one of the things we do is concept of outreach, and it has two forms. One is education, and the other one is these kind of things. Not policy reports, but more science reports. This is a report this is a USA report identifying 4 aspects of climate change that we would consider abrupt: sea level, changes in methane, changes in water cycles, droughts, etc., changes in the conveyor belt. The sea level question, these reports have some value, but in the end you have to understand, with all these reports, we can write these all day and night. In a way, you're still not achieving the science objective. You're becoming coordinated and organized, but the science is only going to be achieved through a commitment to solve it, to make observations and build models. At the international level, you may know of the International Panel on Climate Change, IPCC, who basically synthesize knowledge, scientific knowledge. They don't create it, they just synthesize it. And about 100 of us will get together in June to move forward this synthesis. I had nothing to do with this. The UAE has also done a report on climate change in its own environment and came up with the conclusion that there were 3 things to worry about, and their number 1 thing would be their coastal environment sea level, because they are at the coast. Again, so these reports have great value, but we can't confuse them with the doing of the science. The science is going to be done or not. This is some examples of outreach. This is a bit of an extreme example. There was a rapper guy in Brooklyn who we said, well, maybe we'll try to reach kids, so we'll try different ways, and this is one way. So we gave him all these words like climate anomalies, and then he took them and he made a decent song out of it. He rhymed words that were very climatically oriented. So I'll give you a snapshot of that.
About the earth, really talk about survival. We could talk about the poles where the cold is unrivaled. The Arctic top of the world got people and polar bears. Antarctica, crazy penguins chilling down there on miles and miles of ice and glaciers. But something ain't straight with our polar neighbors. It's a change in the climate, a change in the weather. It's heating up now, but it's not for the better. See, the heat comes down from the sun to the earth, but now the heat can't escape, it just can't disperse because of carbon dioxide from power plants and factories, causing trucks so much more than you could find naturally. So the poles get warm and the earth gets hot. All that necessary ice melts down into water. And the impact, the sad fact is it can only escalate. So for real, we gotta act now before it's too late.
Take aim at climate change.
Take aim, yo.
The he rhymed those words. That was pretty. Climate anomalies and the sword of Damocles. Another thing is outreach every year at the American Museum. We build exhibits with a group of maybe 100 other people, and we build little exhibits with submarines traveling around, and the kids have lots of fun with that and receive some education. In Abu Dhabi, the looking outreach going forward, I think there's enormous opportunity there and a large audience to think about reaching into. What's next? What are we thinking about? Well, I think you can guess it. This is from an NYU point of view. What will be our contribution to this science in the next decade and beyond? And I believe here is one view of what we have on the table and what we can do with it. We have folks, the CHAOS, Center for Atmosphere Ocean Science at the Courant, with capabilities in theoretical aspects. We have folks in NYU Poly who have capabilities with engineering, and particularly thinking of smart instrumentation in the ocean, on the glaciers, and in the ice, at the School of Computer Science and Engineering and Electrical Engineering. We have folks in the Department of Energy, and these are the largest, fastest computers that we know about. There are probably other ones, but the ones that we work with, the Department of Energy, these computing resources are absolutely awesome, and we have access to those. So we're not limited by computers, but we are limited by data. Other resources you need, I'm talking about how is it you're going to get to an end game. You're going to simply give me the equivalent of the weather forecast, but you're going to give me the sea level forecast for this century. How are you going to get there? It's some kind of roadmap like this done by a number of institutes. You need these things. There are only a handful of these icebreakers. They're equipped with helicopters and different things. These need to be somehow attracted and mobilized for this problem. If people don't want to solve this problem because it's not a real problem, then don't bother. But if you think it's real and you want to solve it, you need to line up your ducks. And Abu Dhabi has come on, and that's why we're here tonight. A research institute is there, and it also has a role to play. And in particular, I think if it wants to make a meaningful contribution in the next few decades, where it can leave a stamp and say, we achieved this with our partners, NYU Courant is willing and able and to advance the theoretical aspects of this problem. We don't have a lot of infrastructure, so what I put out there is that if the NYU Abu Dhabi Institute really want to start taking some leadership in observational systems for the planet, new technologies combined with old, that's what's missing, that kind of commitment. And the end product could be quite amazing. So, to end, anyone who gives you a projection of sea level, it's meaningless. We don't have it. That's okay. We don't have lots of things. I think within decades, that's an opinion, with this key word, sustained, if you don't keep your attention on something, you're never going to get to it. And that's kind of a flaw we've built into our own research system in the United States. We quite often cannot keep our attention on a problem that exceeds 3 or 5 years. And that's something, that's the way the system's been built. We're talking about sustaining things for a decade or longer, keeping your attention on a problem to solve it. And it's also changing a little bit. We have to think about, in the US, about our fascination with curiosity-driven science versus problem-driven science. And we're very much driven by curiosity-driven science. And that's what folks and scientists tend to do. What's new and interesting now? That's not how you solve some problems. That is the goal, and NYU's challenge is to make a meaningful contribution along with our large number of international partners that we can say we've done something, a meaningful contribution. Now, if there's some other problem that we should be doing, well, let's do that. I think there are a number of really good problems. This is one, but I'm just saying if we have an obvious some other problem to work on, well, let's work on it. But I'm putting this up as this is the one I think that we can put the pieces together and move forward.
main factors in what will happen here is wind. And the question is whether that is easier to measure and whether that is the facility to do the kind of wind measurement you need is in progress.
Right. So, for example, for the region down here, the Pine Island Glacier, there's no weather station anywhere here. We put one in there 2 years ago, and we went back to get it this year, and we got there and we were unable to retrieve it. So there is no weather station there anymore. That's gone. But we left all the kits we brought with us. We left them over here. So next year we'll go back and put them in. But this is a rather amateur, childish thing with just a few scientists.
Whether Greenland, for instance,
It's
or either observation
much better.
or how you observe wind.
You just put in weather stations there, and that's it. Yes?
I assume these are all in the purview of NOAA. Do you work closely with them?
Yeah, so that's interesting. Our goal is to have NOAA pick up the ball here. NOAA is our National Ocean and Atmospheric Administration. It's the equivalent of NASA, but NOAA's on the Earth. NASA's in space. And the idea is, for monitoring the planet, it's just finite, and you just simply want ocean stations, ice stations, atmosphere stations. That's all you want. It's not crazy. That's the challenge that I think NOAA eventually will take up. But as of yet, no. And no sign they're going to start observing and instrumenting that part of the planet. And nor should they. It's just one country. Yes?
Are you collaborating with atmospheric scientists on the interplay between rising sea levels and the ozone hole, those kind of chain reactions?
Yeah. So that's the conversation that's now starting. So what we're seeing in the southern part of the world is the two changes. The ozone hole appeared in the mid-'80s, and that has had one impact on the winds, and carbon dioxide has increased in the last century. That's had another impact. People are trying to sort out at the moment, those two constituents, what they've done to the atmosphere in the Southern Ocean. First, I thought this was all crazy. Like, I know there's an ozone hole, but you're saying it changed the winds blowing around the ocean, and people are saying now that, yeah, that's actually credible. Nobody has really brought it concretely forward with computer modeling in that, and I think that's where we're soon going. So is that your question about what is the relation?
Because you don't just, it seems there are just more factors in play, and if people don't work together, everybody just says separate research.
Oh, yeah, so totally people are keen, and that's, within a few years, you'll see this much more integrated than it is now. So people are talking. One other point there about the atmosphere I'd like to point out, which is also to keep in mind, if you take an atmospheric model of the planet and you run it, you simulate, say, 1,000 years of Earth's behavior. So there's no ice sheets in it. It's just an atmosphere model. And you run it. It does some really complex things. It has decades in it. This is a 1,000-year simulation with no reference to any particular time. It has decades when the winds are strong, and then times when they're weak. And this is all the atmosphere itself, apparently, having natural variability. And the problem is, if that really is some kind of chaotic response in the atmosphere, then that's borderline unpredictable. So just leave that out there. It's very early days. Yes?
I'm having a difficult time grasping the last slide where you said there was no credible prediction.
Right.
So we're at a point where we could say, and I know the city of New York is concerned about this, it's in their plans, their emergency response plans, that the ocean levels could go up or go down or stay the same.
Seems fair.
That seems fair?
Yeah.
Even though that the IPCC and all these thousands of scientists.
But the IPCC wrote, there's not thousands of scientists, it's us writing, yeah? Is it just like,
isn't there over 1,000 scientists involved?
well, in different parts, say 200 on that question.
Okay.
And let's not put too much responsibility on the scientists here in some sense. With the resources and availability of data and information, IPCC is not creating science, it's just collecting and synthesizing.
Yes.
And within that, it writes a report which I disagreed with the presentation of that information. It said, we IPCC project air temperature. It's like, okay, good. We, IPCC, project sea level. And I'm saying, but how? Why? How do you do this? And they say, well, the ocean will heat and expand thermally. And they put in a number for that. And then they say, well, the two ice sheets could have enormous effect, but we don't have any idea what that is, so we still give you a number. So the responsible thing is, we don't know. You don't know what those ice sheets will do in the coming centuries. So what does it mean to start dealing with numbers? How to say 19 centimeters low bound, 59 centimeters high bound, plus we don't know what the ice sheets will do.
Well, I think.
How is that useful?
Well, a lot of the area where I work is 2 meters above sea level now. Storm surge in Long Island Sound could emerge that area, which stores food, perishable food, for the whole area around New York. I think that we have to plan for the worst.
Okay. So, but it's just a conversation. It's like
the day after the storm surge, when millions of people have no power and no food, science would say, well, we've got to start over, but I prefer we do it beforehand. It's our insurance.
Okay. Yes?
You did address this question a little bit, but I wanted to know, why haven't we put more money into this kind of research sooner? It's not as if there hasn't been funding for NASA or for other projects. I mean, this is an issue that obviously seems to be more short-term. And it has now emerged into, it's critical, it's like at a crisis level. I think everybody is turning and looking at climate change and all the effects it'll have. But why do you think that, even before the discussion began, why isn't it that scientists have not focused really on studying the Earth before they went to study, farther?
Oh, it's funny you should say that, because those are the same questions I ask myself. It's why are you putting resources there instead of here or something?
But have the scientists focused on this too?
The scientists complain about this, but there is much the problem.
Because their energies could be focused elsewhere as well.
Right. So the answer to your question is disciplines. We have disciplines. This is cross-discipline. And so disciplines don't communicate, so no discipline can solve this problem. So first problem is break down the structure we've created, disciplines. Second thing is the fascination with curiosity science, whatever's hot today, I'll lose attention in a year. It's a hard problem. This is not like rocket science. This is far more difficult than putting a man on the moon. You want to solve this. It's going to take an enormous commitment of resources to solve it. And people have to be mobilized. They have to be convinced it's worth doing. And I think that's the change you're seeing now. I think it's happening. At the same time, in 5 years, we could be where we are. And also, just the doing of it is just going to take a while.
And one technical question. You placed a weather center,
Right.
and it was gone the next year.
2 years later, it was buried.
It was buried. What will happen? Will you have to keep adding new ones, or have you figured out a way to protect them better, or
No, yeah.
just technically?
Yes, we
So
have.
if you install them, you're not going to
So,
lose them in the next.
right. So from now on, the ones that we left there in January when we left, while we were there, we did have some time to fly around, and there are rock outcrops in Antarctica, all scattered through the place. They're called nunataks, which means rock outcrop. And so from now on, we will bolt weather stations onto the little rock outcrops so they won't be buried in snow. And so that's what the network will look like in the future. Yes?
I just have some, I just wanted a clarification on what you believe then is the cause, or would be the cause for sea level rise, if there is. So are you saying that you don't believe that we're inducing increases in carbon dioxide, which subsequently warms like the global temperature, or
right.
which are you saying that there's no connection between?
No, let's be clear there.
Okay.
Anyone who says they believe in climate change, I have a problem with. Because It's just data. You don't have an opinion about it. The Earth is warmer.
But you don't think that's because of rises in CO2 levels?
What I think about that actually doesn't matter. And people who study that will provide you the view on that, and that's the best you're going to do. How is my opinion on that somehow better than your opinion? My feeling is that it's right, but I only know what I know, and that doesn't make negative or positive. I'm just trying to be really vanilla plain on it. I can see the planet has warmed, and it's either natural or it's us, and I consider that it's totally plausible that as we continue to warm the planet, that we will see some surprises emerge. That's about it. But in some cases, I find it weird when people put scientists in a place where they somehow know more or have deeper insight. We don't have deeper insight. We just collect and make the data. Does that help?
Well, no, I guess I was just asking if you believe that, like, anthropogenic climate change might be the cause for CO2 rise, and then that would make the greenhouse effect more enhanced, which warms the Earth, and then that would probably cause melting glaciers?
Yeah, I think that is a plausible scenario.
Okay.
And that would be a really bad thing, right?
Mm-hmm.
That's totally, yes, totally plausible.
Okay.
Yes?
Were you implying that there's a need for federal commitment or somebody's commitment long-term, like 10 years at a time, 15 years at a time,
Right.
rather than short-range funding?
Right.
Is that a
Yeah.
major problem?
And interdisciplinary between disciplines and interagency. We have the Department of Energy, the Department of Defense, NASA, NOAA, NSF, etc. And they all have different skills in our country, and they're not together saying, you know, actually together we could figure this out. And I think we're going to see that change. They will get together.
What time period was that $300 million grant allowed?
Oh no, the 300 million is the amount we spend. One of our agencies, NSF, spend 300 million a year to run Antarctica as a hotel. You want the Air Force in there, and these planes and jets and helicopters and all this, doctors, fire trucks, camps. Tick, 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 300 million.
So then what was the 10 million?
The 10 million are the little science budgets extra if you want to go and do something. And then NASA, each time they put up sensors, and our NASA colleagues put up sensors, basically cameras, digital cameras in space that can measure the height of each of those. Are 700 million a pop. So it's expensive stuff.
So my takeaway from this presentation would be that you cannot change what you cannot measure, and right now we can't measure what we need to measure.
We cannot measure a part of what we need to measure. I was specifically talking about the ocean part, but in general, the observational network of the planet is incomplete, and so you have that object in front of you that's behaving, the ocean's moving around, the atmosphere and the ice sheets, they're all changing, and you're trying to project that. You can't really build a computer model of that unless you have a lot of data about how it has behaved. And the data you have right now in hand is very incomplete. So if you build a model, I don't know what it means or what it's built on.
I read an article in one of the Sunday papers that cited a recently published paper that showed evidence that the level of ice at the North and South Pole has actually increased over the last 5 years. This is a two-part question. First, do you know if the paper...
Sea ice or land ice? Do you know if it was ice in the ocean or ice on the land? Or?
Ice, they just refer to the North and South Pole.
Okay.
I'm not sure
Okay.
of whether it was ocean-borne or land-borne.
Okay.
I'm just wondering if you've read the paper or heard of the paper. And secondly, I'm just curious about the fact that you never mentioned ice at the North Pole during your presentation.
Right. So that's a very good point, which I should have brought out. There are two types of ice that we're fascinated with in climate science. There's ice on land, glaciers, and ice that is created in the ocean called sea ice. Ice on land is like a mile thick. ice in the sea is like 3 feet thick, and it comes and goes every year, the sea ice. In the North Pole, the sea ice in the last 5 decades, half of the sea ice cover has disappeared. And scientists are absolutely blown away by that, because growing up into the literature developed over decades, the sea ice is there every year, and then while you're studying it, half of it's gone. So the sea ice story is a huge story, and it's fully, like everything, it's not fully understood why half of it's gone, but it looks like it's because the planet's warmer. In the Southern Ocean, the sea ice has not decreased. So it's a fact that half of the Arctic sea ice has disappeared in 5 decades, and the Southern Ocean sea ice has not disappeared. What it looks like, and this is kind of hand-wavy, but this is where people are at the moment, that the combination of the ozone gas, the carbon CFCs, and the carbon dioxide in the southern hemisphere have set up a situation where the sea ice is not decreased. That's all very hand-wavy, but that's kind of where people are. If that's your question, why has it half disappeared in the north but not in the south?
My question is why you didn't mention
Because I'm not focusing at all on sea ice. Because sea ice, if it melts, comes and goes, it has no direct influence on sea level. But the land ice is the one that affects sea level.
I'm sorry, you had a hand up earlier.
I'm wondering, since this is a time-sensitive issue, while you're researching the data and the situation changes. So what can you, as a scientist, contribute to mobilize forces or to bring them together? Because if these enormous amounts of money are needed and they're all in separate agencies that are not collaborating, let alone international collaborations, how is this going to be solved before it's too late? Because you can collect the data and 20 years later you can say, well, now we know it, but now Venice is gone. So just as simple as that. How can you mobilize enough people to do something preventively, even though maybe your data is 100% complete? Is that really necessary in order for us to act?
So the specific actions we take, for example, this year, last week we had a meeting in Washington where we brought different agencies together and we get them chatting and saying, it's very tricky. You just can't go to an agency and say, do that. People don't like that. So there's a real political aspect that should be apparent to people. It's like, would you be interested to do this? You're very good at that. It's that kind of conversation. So and how we're doing that is, so we have a large workshop set up in DC in June that the National Science Foundation will bring agencies in and say, specifically, it's just 40 scientists and say, develop a plan. Move us forward in our system as it exists. We have a meeting in July, IPCC. That's 100 scientists around the world. Again, that brings in people, and it's talking. I think it's useful, and I think it's the best that we can do to kind of get representatives of different countries playing together. So, and I could go on and list examples. So there is that element called meetings and workshops to drive people together. If someone has a better idea, great. Okay. Yeah.
So how cities should confront this uncertainty related with sea rise?
Could you repeat that, please?
How cities?
Cities? How should they? Cities?
Cities like New York or Abu Dhabi should act in this uncertain scenario.
That's a good question. So I'll just give you opinions. It's my opinion that on the timescale of institutes like NYU's 200 years old, looking forward the next 200 years, there's real probability, you have to take this serious, that you could actually have large change. The response is to either move or to put up walls and structures. And what we're talking about are these perfect storm scenarios going forward. Literally, hurricanes and storms arriving, higher sea levels, high tide of the moon. Put it all together, you flood cities. So you either get used to that, move away, or build protection. It's all, money is not something to focus on. It's just effort is really the right word. In Venice, because they're sinking, so they're building barriers, and it's big effort. but they're tackling it. So,
They're still sinking.
what's that?
They're still sinking.
They're still sinking.
And they're,
They have these.
thing they've invented, those barriers don't even
Yeah,
really work.
that's what I was afraid of. It's
But it's a good effort.
It's a good effort. Yes?
A couple other variables is, you know, if you throw out some numbers, 21 feet. Is that 21 feet, is that around the globe, or is that bolted out more around the equator?
Yeah, it's
You know, that sea level rise. And then the other thing is, you know, the plates are responding differently. You have,
right.
you know, glacial rebound, and also you have different variables depending what city you are, you know.
Yep. So that's a great thing. That's the next step. It's called regional projections. And that's where the World Climate Research Program and other organizational bodies want to take us. Moving away from this fuzzy picture of the planet will warm and sea level to regional, as in your country or your coast. And for those of you who caught it, the complexity that was just referred to is, so if I take a drop of water here and I throw it into the ocean, the response on the planet is relatively complex. Basically, if you put a piece of water in, it will travel out as a wave, and a wave travels at the speed of roughly an airplane. So if you put water in, well, tsunamis, you see that when the plates shift, they make waves. They travel at the speed of airplanes and spread out. That's how sea level changes. It changes fast. But when you take ice from here and you put it there, the bedrock here begins to rise. The plates respond, and that's a change. The other thing is the actual height of the ocean. This is a more subtle point. The height of the ocean is determined by the speed of the currents. So out yonder we have the Gulf Stream, and it moves like a jet to the ocean. And the sea level around the Gulf Stream is about, I think it's 3 feet higher than it would otherwise be. This is called ocean dynamics. And if you change currents, you change the height of the ocean. The other one is surprising, is gravity. So you know the moon is out here somewhere, and the moon goes around, the Earth spins, and the moon is there, and the sea level goes up and down everywhere about 3 feet every 6 hours. It's the tide. This body here is a tide. It's like a little moon. If you remove this body, sea level all around here actually goes down. The planet sea level will go up. If I take all this ice and I melt it, the whole planet goes up 200 feet. But locally here, it will go down about 200 feet, because right now, today, the sea level near ice sheets is pulled up by the gravity of the ice sheets themselves. So these are all complications. You can calculate them. So yes, regional projections would involve all these extra complications. Yeah?
I gather from your position that you and James Hansen don't get along too well. He's been, he has his models. I forgot what particular agency he works for.
NASA.
NASA.
Right.
And Keating and the CO2 rise that's now approaching 400. It started at 280. So do you feel like he's gone way beyond where the data would allow him to go properly, and that he's over-dramatized the situation?
Not at all. I think people have their opinions, and they can go high and low on this, and that can all be useful in the sense of a conversation. I'm being specific in terms of if you have to say you have a projection, then at the moment, all cards are on the table. All things.
So a formal projection of
sea level.
Sea level.
That I would want to spend trillions of dollars of infrastructure depending on, saying I'm going to build dikes here, walls there, trillions and trillions of dollars. That confidence doesn't exist. But the fact that sea level could go up or down, that uncertainty does exist.
Okay. All right, so some variability, some plus or minus.
Yeah, and we're trying to figure that out. Yeah.
You mentioned getting the global science together to agree to, or politics or whatever, the Earth to agree that there needs to be additional research here. And you also said that there is a curiosity-based science and problem-based science. Can you explain a little more what the curiosity-based sciences are in your opinion?
Yeah, curiosity science is generally within a discipline. I sit down and say what I want to do. And that's how we've learned pretty much, I guess, most things how we've learned. You know, how do we come up with stuff? It's people go and explore and they discover things. Either they build things or they find ideas. And it's fantastic, but it's random. And it means that you just do it and you learn what you learn. Now, if you have a problem to solve, that's not how you go about solving a problem. Does that distinction, does that help or not?
Yeah, well, I'm
okay,
curious
so,
how then do we...
Well, let's look at...
I guess you'd say that you need to take money from curiosity and put it into problem.
I'm suggesting if you said you wanted to solve that problem, you either have to shift funds or create new ones. So our science agency, their pot is just $7 billion. That's curiosity-driven science in the United States. And then there's other parts more directed. The other departments tend to be a bit more focused. But NSF, it's a democracy. Tell us your great idea, and us, the peer review community, will look at it and say, your idea is great, we're going to support it. That's a curiosity, idea-driven science that is limited by the individual. It has no real scope for solving big problems. And I'm not saying that it has to, but I don't think it has that capability.
Is it clear what's problem-based and what's curiosity-based?
Well, for me, yeah, if you said, here is support, a resource, an effort, and give me your best idea what to do with it, that's kind of borderline curiosity, and you compete ideas. Whereas if you say, I want to solve a particular problem, I want to know the height of the sea level there for the next century and beyond. If that's your question, and then everything has to fit within that question, that's very uncomfortable to scientists. That's problem-based, focused science. Yep.
So I'm struck by your, as a number of people I think are, by your agnosticism as various questions are asked. And a number of aspects of that. First of all, your rapping colleague didn't seem so agnostic. I'm wondering what
I see that. And I see these different colors and flavors of people, their passion for the science. I tend to be a little bit drier, but I'm no, is that what you're getting at? Like,
I'm getting at
people
also,
making it more dramatic or less dramatic? Is that the element?
Well, I'm actually, I thought that effort is part of your outreach.
Right.
Yeah. So first of all, I want to know if it is, and hence you're the sponsor of this non-agnosticism. So that's the one part. The other part is that you said part of the problem is the discipline base of all the participants, and yet this is a transdisciplinary phenomenon. But in a lot of what you said to people, you were in effect saying, I am just of this discipline, and therefore with my delimited sensibility and data sets and orientation of the world, I can only have an opinion that's as good as anyone else's. And so my question is, if everybody is limited by the fact that they are just in a discipline, then who is going to, in effect, represent this larger perspective other than the rapper?
So I almost got your question there. So is it?
Well, first of all, concrete questions. What's your relationship to the rapper?
Right. I think
and then the second question is, in effect, I'm challenging you that because if not you, who? In terms of providing the public with a larger perspective about what the likelihoods are one way or the other, and hence what a strategic action might be, other than, say, walls.
Okay, so I don't like to go with the kind of the response thing. The idea that somehow I go and measure temperature at a glacier and then somehow I know things that you all don't know is ludicrous. So I just want to come from there. I don't know more than you, okay? What we actually know is very thin. And I think the information I presented is kind of stuff we know. Then we have opinions. Climate change is intense. It's fake. It's all this. I don't know what to do with all that. If it's part of that about do you believe in it or not, I have no interest in that. I can just see in a dry sense these data sets and these problems, and you try to separate that off. That's what I'm trying to do with the agnostic part, is what is it that's really for real? And the fact that some people then want to say, I'm really concerned, and they form it into a rap video and says the climate is changing, and et cetera, I don't have a problem with that. That's your opinion, and that might be a good thing. You might be doing a good thing by that. So does that help at all in terms?
Well, first of all, just a concrete question. What is your relationship to the rapper?
He
pay for that?
The National Science Foundation paid for that, yeah.
But that isn't under the Courant grant or anything. That's a separate.
Yeah, it's a separate thing from an agency in New Jersey called Polarpalooza, which is funded by the National Science Foundation. That man in New Jersey went to the National Science Foundation and said, I want to do outreach. That's what he produced. We are in the video. We're running around on the ice in that. And it also connects with kids when you go to schools and museums. They say, okay, so polar bears are in the north and penguins are in the south. There's ice and glaciers. And he's got a catchy voice. That's it. Yep.
I completely understand where your position is on climate change, and I'm just wondering, it just brings me to a question of how you feel about conferences such as GROC and things like that. What actually concrete or substantial data are they actually presenting to CEOs and people in high places? Like what is actually pushing with things like that?
You can tell me what GROC is.
What's that?
What is GROC?
The Global Roundtable on Climate Change.
Okay.
They actually gather large heads of corporations,
right,
like GM,
okay,
things like that, and they actually take them through a 2-day conference and kind of convince them about climate change and things that they can do.
It's relatively straightforward. In its simplest level, right? One planet, atmosphere, ocean, and ice. 7 billion people running around on it. Out of control, probably. Putting carbon dioxide and changing the atmosphere. The end game, well, there is no planet, just running around on it, right? So the idea that somebody would want to concern and think about the big picture is useful, but it's going to, if you're saying that what can be the outcome, I think the outcome could be tangible things like decisions. You have to decide whether to cut carbon dioxide emissions or not. There's a lot of decisions you have to make. Those decisions will be made with imperfect information. Yeah, there's no way you're going to. If you knew for certainty the sea level in 100 years was going to be an exact thing, you could just take simple actions that respond to it. But we're in a position that we don't have that. So that's not really answering. So what is your
So I guess
direct
my
question?
question is, are things like that just useless?
No, I think it's great. I think it's conversation at one level is good. But people have to also appreciate, I guess I have a slight criticism, not at that organization, but in general. If you're going to talk about climate change, well, there's a point I would argue you need to walk about climate change. You need to just do the science. Yeah. Yes.
You know, I think what's throwing people for a loop is the fact that there are two conversations going on. People who believe in climate change because they think there's the science to back it, and they become passionate about it because they believe there's the science to back it. And then there are people who say there is no science and we don't believe in it. And now you're this third category. Let me tell you what I'm hearing here.
Yeah.
And now we have somebody who says, I really don't care about the actual debate of whether it's man-made or it's natural or whatever. I just want to tell you that we don't have enough science for this particular problem, which has to do with rising sea levels. And I think that for me, it's a refreshing kind of approach, but I'm just listening to the questions that are being asked, and I think that that's what's confusing. It's like people who have suddenly, discovered the environment and are just not the people who are so passionate about saving various animals, the trees, the natural beauty. Suddenly there's a sense of urgency, but they feel that there's all this science to back it. And then you're the people who think, nothing's changing, there's absolutely no problem, we should carry on. And the big scandals about whether there's true science, whatever. And now you're approach,
Right.
which I think is, as
Well,
I said, it's.
Yeah, so I would say anyone who thinks they know anything about what that plan's going to do, rubbish, meaningless. You don't know, and that if that puts you into a concerned place, okay. But I'm saying as scientists, you see, it always goes to opinion. You find it scary. That's an opinion, right? The fact is that we have this suggested evidence that there could be abrupt changes. We've seen it in the past, and we may see it in the future.
But you're talking about if it's going to accelerate. I mean, we know that it changed afoot in the last 100 years. We know that it varies, several tens of feet in the last 1,000 years. We know that. I guess the question is, how much more is it going to raise more?
Right.
I mean,
It's a pretty dry question, isn't it? That's all we're trying to do. Is that?
I think we need to free David to continue his report.